Okay, so now we are starting with the actual workshop. This is lecture number 3 or video number 3 in this workshop. And this geometry is based on I told you this is based on this paper, which you can see over here. This is the dimension for the domain. So these are the domain. I told you that thing in the very first lecture on the ML bodies workshop, which you can find over here. So all details are given in the first part, the lecture number 1, in the section number 4. So you will get all this data over there. So domain size is based on the recommendation by the European community, research community on the turbulence, and that is following those standards. And also this is also adopted by the many good papers. And these 3 bodies you can easily create inside the space claim. And if you want to have the more information on the space claim, you can see my other courses where I have explained the space claim commands. So anyhow, these are 3 boxes, and we call them as the body of influences in the Fluent or in the ANSYS. So what they do is that they basically refine the mesh with a constant size, element size inside the domain, which is over here. So locally you can define the mesh. And as I told you earlier, and also I've shown you in the paper, also in the original paper, that the 85% drag is coming from the body drag is coming from the pressure drag. So that's why resolving these components, these wake, is very, very important. Okay. So you will get this file. You have to import this file with the name as M3BOI, 3 body of influences. Okay, so I will close this app. Maybe you can just keep it open here. Maybe we have to reference some time. And now I will open the Fluent. It's a Fluent 2020 release 1. And this was the previous workshop on the T-junction. And I hope you liked it also, and also the method I taught, which is the Fluent fault tolerant meshing. Okay, so also second section is not there. So second one is over here with the results. This is the mesh file. The first one was the Fluent file. This one is the mesh file. Okay, so we start with the meshing app, and don't turn on the double precision because this will take a lot of time in the Fluent. So I will set the working directory to be the mth body, and everything else is okay. So click on start. Okay, so we have the 2 options, workflow and the outline view. So outline view is basically if you want to work in the traditional way in the Fluent meshing, that is known as a T-grid also. But we are using its latest feature, which are the workflow based simulation. And here, because geometry is very much correct, and we have the domain also, and also we made the 3 boxes for the body of influences. So that's why in this case we are going to use the watertight geometry workflow. And you can see all these options, and also discuss this thing in the very first workshop on the pipe. So if you want any information about the watertight geometry workflow, you can go through the first workshop. And that is given over here. Simple pipe meshing using watertight workflow, WT workflow. Okay, so import geometry, and geometry is made in the meters. You can see the units you are seeing here, they are the meters. So that's why I will choose the meters here, and all dimensions for the geometry sizing I will be providing in the meters as well. And then you have to browse for the file, for the geometry file. And this geometry file is the original file which I got from my mastering ANSYS CFD level 1 course. And I just made the half body, and I added the 3 body of influences, and that's very simple to do. So you have to open this file, m3boi.sc doc, and click on OK. And also you can open even other formats, like you can open the SET, SEP, STEP, IGS, and other formats. For other formats, you have to choose all files. Okay, so I will be clicking on the OK now. and there's no need to click on import geometry. This will import geometry directly. Okay, so now we can hide some boundaries here. Also, you can use clipping planes. So the clipping planes basically will help you. So right now it's a Y direction, and simply click on the flip so that we can see the geometry from this side. Okay, just make it slightly inside. Once it is inside these three boxes, you can clearly see the geometry of the MN body. Okay. Anyhow, I will be not using this clipping planes right now. I will use the feature in the Fluent meshing of hiding the geometry feature. So I will select the geometry. Okay. Second one is on top side. Okay. Also these three boxes. So sometimes it does not select. So you have to get it closer to your screen, like you can see here. Okay. And also I will discuss about the geometry in the detail here. So what we are doing is that basically, if you take a look on the geometry file, you can see that we have three bodies of influences. They are not merged with the main MN body with the domain. Second thing is that in the groups we have defined the inlet. That's very normal thing. Outlet, definitely we need outlet also. The road is on the bottom side. The side is over here. This will be a slip condition. So I will use a slip condition here. Then the top, symmetry, which is over here. Legs, which are on the bottom side. And then I divided this MN body into the multiple parts because we need the separate mesh, and also it should respect these lines between the intersection. So otherwise, if you don't make the different boundary conditions, different groups or the name selection, the mesh will not be defined on these edges. Otherwise, these will be like fused to each other and you will be getting the very diffuse mesh. So that's why I had to make these all sides here. You can also group them in the Fluent. That will be much easier for you then. And the back side is over here, and straight face, which is over these three sides. So also I need to make them separately. And interesting thing is that I define the same sizes for all the faces, but still I need to make them separately. That's a very important thing. Okay, so now go back to the Fluent. And then I want to add local sizing. Yes, I want to add a local sizing. And if you take a look on this slide that you can download from the files on the same workshop, and this also you can find in the master PPT file, you can see that the three BOIs, they have the sizing defined here. So I will start with these three BOIs. Okay. In the file, maybe you see in a different way. Maybe the body of influence are added later, and the first we have the face sizing, but we will do that thing first. So body of influence, select them from here, and the first body is here, and set the size as the point. It is written here, so it's a 0.03. So 0.03. And do you want to draw any sizing here? Yes, it shows in the green color the size of the mesh you will get over here. It's a 0.03. You can also put the 0.03 meters over here. That's in the meter because geometry is meters and sizing will also be in the meters. Okay, so you can also see the meter written over here. Now click on add local sizing. Then again I will choose the body of influence number 2, and this time this is the 0.045 meters. 0.045 meters. And the body of influence are very important for the blunt bodies like the Ahmed body. Otherwise you won't be getting the drag penetration very correctly. So second body of influence is over here, which we just hidden from the view. And click on the add local sizing. That is now with the 0.045. Okay. The third one is with the size of the 0.06. 0.06. and this is the BOI 0.06 meters, and click on the add local sizing. This is the size of 0.06. Okay. Now click on add local sizing. The next size you can see over here is the sizing on all the surfaces of the ML body. So I will define the face size, and the face size I'm going to define is the 0.005 meters, and that I will define on all the parts over here. You can select them also from screen. So add local sizing 0.005 meters, and this is on the back side. The curve faces which are on the front side over here, the front face which is here, the back side on the back side, this one. Okay. Then we have the slant face which is the angle of 25 degrees. The next one is the 3 straight faces, 1, 2 and 3 on the bottom side. And now click on add local sizing. The next size I'm going to define is the 0.002, and that size is on the legs. Okay, so I just want to confirm that we have the proper size. So you can click on revert and edit. So the size was not correct. It should be 0.005 meters. Also click over here and edit. So this is going to be the 0.002 meter. This is in the name. So this is just a title of this face size. Otherwise it has no effect on the sizing. But the size we are putting over here should be the 0.002. Okay, click on update. Okay, now just check we have the proper sizing. Yes, 0.005, 0.002, 0.06, 0.04, 0.03. Okay, so these sizes are defined. And for the local sizing on the surface mesh, I'm going to put the size to be the minimum size I'm going to put is the 0.00001. The maximum size I'm going to put is, you can see over here, this is the 0.208. Although I have defined this size to be the 0.08, but let's say I just keep it 0.1. Okay, so 0.1 will be off like this. So just keep this one as a 0.1, and growth rate is a 1.2, and size function is curvature proximity, and the number of cells per gap. These are basically, I'm going to define them as the 12. Okay, so we have the 12 cells in the gap, and why we are doing this thing? Because I need the fine mesh in this gap. Otherwise, the prism layers may collide, or maybe there will be only one element between the prism layers on the top side, which is on the ML body and on the rod. So that's why I am doing that thing. And the scope proximity to the edges, faces, or faces and edges both. So I will choose the faces and edges both. Why? Because edges means that we have the element will be from edge to edge. Face means this is from surface to surface, but I want to add them to the both sides. So we can have the elements between the faces and also between the edges. And then that's okay. So now, and also I change the minimum size to the not to the 0.40 but 0.0001, and the maximum size is 0.1. Maybe you can try with the 0.08, but I will be stopping over here. Because why? Because the BOIs, they take care of the sizes in the vicinity of body. So even I created one body of influence in front of the ML body, means surrounding this ML body. So with this surrounding BOI, I ensure that the mesh in front of ML body is also fine. And because of also the curvature proximity method, it's also ensure that the mesh will be refined in the region of the boundaries. So now click on generate the surface mesh. And this should not take a lot of time because this is very, very fast. As I told you many times, as compared to the ANSYS meshing, this is very, very fast. And even as compared to the ICM CFD, the Fluent meshing is very fast, very quick. See the progress, it is already done 75%. And so size function is attached. It is done, remeshing. So you can see that the progress is very, very, very quick. Okay, so maximum skewness quality is a 0.422, and I told you many times that the 1 is the worst quality in terms of skewness and the 0 is the best. And for the orthogonal quality, the 0 is the worst and 1 is the best, is the opposite. Okay, now I can select this boundary and height from here, and you can feel that we have the 3 zones of the influence, or BOIs, body of influences. The one is around the body, second is the second wake region, third is over here, and then we have the maximum size element as we described earlier. And if you make the size maybe the default one, that is the 0.2. So let's try this thing, and this maximum size does not ensure that we always get this size, because this depends on the surrounding surface mesh. If the surface mesh is not it is not growing at the same at the rate of 1.2, but if it does not reach to the main volume, so maximum size will not always reach, and so is the case with the minimum size. So again update and see the difference with the maximum size here as well. So with the size of maximum size of 0.2, it should also even take the less time. And first I will discuss about the different mesh elements and the different surfaces of the ML body, and especially the gap between the ML body and the rod, and then you proceed with the other commands over here. And now you can see the mesh. So let's hide the side boundary. The side boundary will be slip condition, and so is the top boundary. And this side boundary or symmetry boundary will be symmetry boundary. The rod will be wall. This is the velocity inlet. This is the pressure outlet, and this is the ML body. So you can see the mesh, how this looks like over here. So I was talking about this thing. So if I hide this ground or the road boundary, you can see that I was talking about this thing, that we have the now more elements in the gap here. Okay, that's what I was talking. So you can see the elements on the other boundaries are very large, but here the elements are very small. Okay, this is what I was talking about. And also we have the refined mesh on different regions, especially on the slant. Okay, I can add the one thing more, that is to refine the surface mesh. Okay, so this will improve the mesh quality, and it will may change this clustering of elements in some particular locations. So it may get it corrected. So let's try with the surface mesh improvement. So just right click on surface mesh and it will give you many options. So add the improved surface mesh. Okay, now zoom it. So it's okay. We will proceed anyhow. Okay, so the next thing is the describe geometry. This geometry consists of only solid regions. No. Geometry consists of only fluid regions with 0 voids. Yeah, this is the correct operation. And say no for the other two options and click on the describe geometry. And then we have the ML body. So we have these are the walls. You can see these all are the wall conditions. These are all surface for the ML body. The inlet is the velocity inlet, legs are the wall also, the outlet is the pressure outlet, and the rod is the wall, side is not a wall, it's a symmetry. I will change it to the no slip condition in the Fluent. And why I'm making this as the symmetry, because the prism layers, they will grow on the walls. This is the default operation in the fluent meshing, that it will only create the prism layer on the wall. So any boundary that is defined as a wall will have the prism layer. So I don't want to grow the prism layers on the top boundary, on the side boundary, because this is where we don't need any boundary layer. So just make them as the symmetry, these three boundaries, side and the symmetry itself and the top, which is over here. Okay, and the road is the wall condition, and so is the MN body. And click on now update boundaries. And MN body is a fluid region, yes, correct. So update region also, just don't do anything else. It's already these options mainly, whatever options you see here, they are already there. So you have to, many times you have to just click on the okay, or maybe add something like that. Okay, so here I'm going to add the 25 layers, and I will slightly modify this this option here. Maybe I make it 0.3. And in the case of the watertight geometry, I told you that we don't have the split prism option that is available in the fault tolerant meshing, and that is only with the hex core elements. Okay, even with the poly hex core elements, we don't have the split prism option. Okay, now proceed with the add boundary layers, and now after that click on the generate volume meshing. So I'm going to create the mosaic meshing, that is the poly hex core, and now click on the generate volume meshing. Okay, so you can see the progress of the mesh generation. And at the end of the process, it will show you the time it took to make that mesh, and also the minimum orthogonal quality. It's a 0.044. That's okay. And it took around 2.95 minutes, and the number of cells are 2 million, 2.04 million. Okay, that's right. Okay, so also there, this is saying that you can click on the revert and edit, and go to advanced option. That is the you want to avoid the any collision between the prism layers. So for that you have to click on the yes for the check self proximity. So you can click over here and you can update the process. So this will again generate the volume meshing. And I don't think so that this will solve the problem of low quality. This is what we get for this complex geometry and with the prism layer. So this is the like a very common thing. So don't worry about this thing, and now proceed with the solution. Okay, so even after the turning on the option for the check self proximity, the same quality is there. Now I will just check the mesh quality there and draw the mesh layer. So you can see this is not looking good. So what I do is that I will be writing the mesh file. So file and write, and I will write in some separate folder, because I don't want to overwrite my already existing mesh file. So write the file, and at the same time open the new Fluent session and close the old one. So close this one. The new one is over here. So I will just set the working directory to the F drive and click on the start, and meshing should be a option over here. So with the meshing option, I am starting the Fluent 2022 release 1. And why? Because it is sometimes we get this problem that the mesh is not displayed properly. So for that, save the mesh file and again reopen the mesh file. A second benefit is that because of that thing, you understand that how to write the mesh file and then how to open the mesh file again in the Fluent. So file and the read mesh, and this is the file we have here. and click on OK. Okay, let me check that which file we had exported. Okay, it should show us the latest time, July 12 and the 140. Yes, correct. And as soon as you open the file, you can see that this is the extra folder. It is written over here. And now I hope you can clearly see the mesh. Okay. So now I will be using the clipping planes, limit in the Y direction. Click on the flip. So you can see the mesh from inside, and as well as after creating the boundary layer, you volume meshing can see the boundary layer as well, and this boundary is very, very fine. And also we don't have any collision between the boundary layer on the road and as well as on the ML body itself. You can see over here. Okay, but as it goes on the front side, it gets increased size because the element size is increasing, and so is the mesh size. So if you limit the maximum size over here, let's say to the 0.08 as I did previously, so this size of the prism height will be reduced. Okay, this is the one advice for you. Okay, so now I will close this meshing app, but instead of closing the meshing app and then starting the Fluent, also before that I want to show you the mesh from on the volume level. So I will move the clipping plane towards ML body, and once I get the cross section, I will draw the 3D cell layers. So this is how mesh looks like from the inside. Okay, you cannot see the very fine mesh over there in terms of these hex core elements, but it's very clearly observable on this level that we have these 3 zones for the refinement. One zone around the body, second zone over here, third zone over here. Okay, so I was telling you that you can, instead of saving the file and closing the app and then opening the Fluent again, you can do it from here. So click on switch to solution.